28 cadets, sorry. 28 present, so barring me, there are 27 cadets. You all are in a hostel too, so all of you have got a good access to the internet. And well, let me say, remaining 7 cadets should have been over here. I don't know why they are hiding. So dear friends, we were discussing this particular problem yesterday, and here is a truss, a simple bridge truss it is, and you can see that it has a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 joints. J is equal to 12. And who will tell me how many elements it has? How many members it has? What is M is equal to in this case? Who will count M and tell me? This is 1 M, this is second M likewise. Tell me the number of M.
Thirty.
30, 30.
So is it 21?
How many?
21.
21.
16.
Listen. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
21, yes, sir.
So 21 is the correct answer.
Yes.
Now joint J is equal to 12 and m is equal to 21. This has a one very nice relation. You will almost in every good truss, you will find m is equal to 2j minus 3. Later we will study what happens if 2j m is bigger than 2j minus 3, or sometimes if m is a less than 2j minus 3. In that case, there can be certain issues. We have to look later on, but remember this figure. M, the number of elements, number of members is equal to 2j minus 3. If that happens, that is particular stable. Okay. Well, today main thing is that we have this particular truss, and we are knowing these external forces which are given, and these external forces which are given. This reaction 40 and 40, it was not given, but we have calculated it already. Should I discuss in detail how to find out these reactions, or all of you know how to do it? Do not hesitate to say that you want to know it. Don't worry.
Sir, if you can, repeat it, sir. Yesterday your voice was also very low.
My voice, you mean to, what do you mean to say? Speak.
Yesterday your voice was cutting in between, so if you can repeat it, sir.
Yeah, sure. Why not? Yeah, fine. Okay. Now, we have to apply a law of equilibrium over here. What does the law of equilibrium say? Any rigid body, any material body is in equilibrium. That is, it will not be accelerating in any direction whatsoever, provided sum of all the forces on it is 0. Sum of all the forces is 0. That is, sum of all the, for the x direction is 0 and a y direction also is 0. Let us say this is R1 and this is R2. If I write that sigma of a Fy is 0, then R1 plus R2 minus this 8, this 8, this 8, this 8, this 8, there are 10, 8. So minus 80 is equal to 0. Look, all the 8s were in downward direction, negative y direction, so taken a negative. So R1 plus R2 is equal to 80. This is the first equation I get. Now we have to find, we make a use of an equation, sigma of a moment is equal to 0. About some point, which point we will select? I will select point A. Sum of a moment about point A is equal to 0. If I do it, what is the moment of a R1 about this? R1 is passing through this, so its moment is 0 over here. Now here, assume that this distance AB, BC, CD, DE, EF and FG all are equal and all are equal to A, right? So now, moment of this 8 is 8 into A, it is clockwise, so it is negative, minus 8A because of this and this, minus 8A. Moment of this 8 is minus 16A. Moment because of this A also is, so minus 16 into 2A. Minus 8 into 2A is 16A. Of this 8 also is a minus 16A. Moment of this 8 is a 8 into 3a minus 24a. And then this also is a minus 24a. This 8a into this 8 into 4. So minus 32a, and because of this also is a minus 32a, and that should be equal to 40 multiplied by 5a, or plus 40 multiplied by 5a is equal to 0. What does it mean? It means something very interesting, that 40a, so sorry, this is not 40, this is R2. It will be 5R2. That is equal to 5R2 here, not R2 into 5a. So 5a R2 equals sum of all this. And if you sum all of this, Magasam, it will be 200a. A gets cancelled, so R2 is equal to 40. Clear? Understood this? If R2 is 40, R1 also is 40, because R1 plus R2 is 80. Is there anybody more curious about? Would like to discuss it again? Don't hesitate. I always look forward to a questions from you. So we have a 40 kilonewton force over here and a 40 kilonewton force over here. Now, this is a method of joint. Method of joint, and first I take a joint number A. If I come at a joint number A, then there are two possibilities. There are many possibilities. One point is that 40 kilonewton force is acting over here, and AH may be in a tension. If AH is in tension, then AH is giving a force in this direction. AB may be in a tension, and AB also may be giving a force in this direction. Now sum of these three forces is 0. We know the direction of this, and a direction of this, and a magnitude also, but we do not know the magnitude of this and the magnitude of this. Again, we are not sure that if this is a tension, or maybe it can be a other way around also. It may be other way around or not. But can these three forces be in equilibrium? Can their sum be equal to 0? Have a look. Dear friends, I assume force AH in this direction and AB in this direction. Now let us take all the X component. This 40 kilonewton is a fully X. This AH is having a this much X component. AB is a fully Y, it does not have a X component. Now let us take a Y component. 40 kilonewton cannot have a Y component. 40 kilonewton is totally a Y component. It does not have a X component. AH has a x component like this. Now look, total x component is a upward and a total so total y component is positive and upward, and a total x component also is a positive and a rightward. They are not zero, so it cannot be so. Just apply your excellent common sense over here. At this point, force in a AB either this way or this way cannot give a component in a y direction. Only a AH can give a component in a y direction, and that component has to be equal and opposite to this 40. So AH should be in this direction only. Is it acceptable to you?
Yes, sir.
Right? Then and then it will be having a component like this, and it will nullify the vertical force at a point A. Now that will not do. You have to nullify the component in a horizontal direction also to be 0. In that case, now let us think again assertively. Our AH is in this direction. It cannot be anything else because it is matching with a cancellation of 40. So AH is this way only. So its x component should be like this. In that case, our AB must be opposing it, isn't it? Am I right?
Yes, sir.
So now, with this much thinking, AH is this way and AB is this way. Of course, magnitude here is not known. Go and take a closer look at what we have done. This is our joint A. Forty kilonewton. 40 kilonewton over here. This angle is theta. FAH is in this direction and FAB is in this direction. Okay, so F that is equal to 40.
Your voice broken.
F So friends, we have seen that FAH is equal to 40 divided by sine theta. Of course, the value will depend upon a sine theta. We are solving a general problem, a generic problem, partially generic that is. Now, who will tell me FAH is bigger than 40 or smaller than 40? Cadet?
Smaller.
Say bigger.
Bigger is the correct answer because sine theta is always less than 1. So what I want you to admire is that this support reaction is 40 kilonewton, but even then the force in a AH is more than this 40. Okay, now let us find out what is happening in a AB. We go and look at a joint A till further. Now, FAH, its component over here is a FAH cos theta. That must be equal to FAB in this direction, isn't it?
Yes,
So
sir.
FAB is equal to FAH cos theta. This is our FAH. This is cos theta. If I manipulate further, this becomes 40 by tan theta. Now, let me tell you something. Tan theta will be always bigger than sin theta in the first quadrant. So, FAB is 40 by tan theta. Tan theta is bigger than a sin theta. As a result, FAB, now again, tan theta may be less than 1 or a more than 1. Depending upon that, we can find out the value of a FAB. FAB will be either more than 40 or less than 40. It depends upon. But theta will be larger than 45. So tan theta is bigger than 1. So FAB is likely to be larger than 40. Okay. Correct. Now, next 10 minutes discussion is very interesting. AH. Oh my God. Sorry. AH is giving a force to this point, is pushing the point A. This is an element AH. It is pushing the point A. So AH is pushed by the point. So Node A is pushing the element over here, so node H must be pushing the element over here. So now tell me, AH is in tension or a compression, my dear friends?
Compression.
Very good. Very good. It is very obvious. It is not that I thought I am giving you a very smart question, but sometimes, it is required. Here we have found out that AB is pushing the point A. That means if it is AB, AB is pulled by the point. So this also must be pulled by the point. As a result, what can we say? AB is pulled at both the ends and AB is in tension. In some book, some author, what do? They always assume all the element in a tension. It is like this and it is like this. But then you get an answer of AH in negative. So you come to know that it is in compression. And you write compression. Some people assume that this point, this is in tension, this is pulled, this is also pulled, this is also pulled, this is also pulled. Then they find out the force is a JK, LK, CK, DK and a EK. What all the forces come positive, their tension is correct. Where answer comes negative, they are in a compression. But I personally do not do it. You can have your own way. Okay. Now having worked at a point A, we have a knowledge of a force over here and here. So we can come to this particular joint or this joint. Let us see what we want to do. What I have done already. Yeah, I have come to the joint H. Yes. Yeah. At joint H, there is a external load 8 kilonewton which is acting, that we know. Then this is a force over here which is FAH. FAH is a 40 by sine theta, we know. Correct? Now, this is a only inclined force. So it has a x component in the right direction. To nullify that, FHJ must be in this direction. Now 8 kilonewton is acting downward. Component of this is acting. This is a 40 by sine theta and its cos component is acting upward. So 8 minus this component is equal to HB. Let us see what happens. First of all, I assume FHB downward. FHB plus 8 is equal to FAH into sine theta. So FHB is equal to 40 minus FAH sine theta. Now FAH is equal to 40 by sine theta into sine theta. So it is 40 only minus 8. So float HB is a 32. Of course, I should not forget to write kilonewton. Don't repeat my mistakes. Always write a number and a unit. Do not forget, because examiners are sometimes in a mood to cut the marks by any means.
Excuse me, sir.
Yes, my dear.
Sir, how come we know that FA?
How can you know what?
How come we know that FA sin theta is opposite to FHB and A?
Yeah, okay. This is a force FAH, isn't it? It is in this direction only, that is sure.
Yes, sir.
Right? There is no other way. So it has a x component in this direction and a y component in this direction. Am I right?
Yes, sir.
Okay. Now, this x component and a force because of a hj must nullify each other.
Yes, sir.
So FHJ must be acting in this direction.
Yes, sir.
Right? So FHJ direction is this only, and its magnitude is equal to FAH into cosine theta. FHJ is equal to FAH into cosine theta. FAH is a 40 minus sine theta into cos theta. So 40 divided by tan theta. Done, my dear boy?
Okay, sir.
Is this clear? Do not feel shy. You can ask me 3 times or even more than that. Correct? Acha. Same way, this is a force. It has a upward y component. So 8 minus this upward component should be FHB in a downward direction. So FHB plus 8 should be equal to FAH sine theta. Now FAH is a 40 by sine theta. 40 by sine theta into sine theta is a 40 minus 8 is a 32. So our FHB is a 32 like this. Got it, dear friend?
Yes, sir.
Right? Now, one thing. Element AH is pushing the node. So node is pushing the element. So AH in tension. FHB is pulling this. HB is pulling this. So node also is pulling it. So HB is in tension and HJ, this HJ is in compression because HJ also is pushing the node. So node is pushing HJ. So HJ in compression, HB in tension, HJ is in compression, that we know already. Clear? Right? So we can very clearly say that this is in compression. Sorry. This is in compression. This is in tension. Right? This also is in compression. And this is in tension. Okay. Now we come to the node B and see what happens. joint B. So बच्चों, first of all, let us see the situation at a joint B. At joint B, this is the external load at acting like this. HB is in a tension. So here we have a 32 we have find out. So we have a force 32 acting upward. Am I right? FAB also we have found out. So what we have to find now? FBJ and FBC. My calculations are in front of you. Who would like me to repeat it? Just check. Have I made any mistake? Or I'm alright?
Sir, can you show this joint again in the full diagram?
Full, acha, okay. This joint, this is a point B, joint B. It is, I will tell you. If I show you the joint, then this picture will go away. But don't worry. It is a joint over here. Do you see it?
Yes, sir.
Point B.
Yes, sir.
Acha. So work. Make a mistake. Do not worry. If you make a mistake today, then you will not make a mistake anywhere in your life while solving a truss. Okay? Let me draw it here again. We are at a point B over here. You can see that this FAB is here.
Yes,
FAB
sir.
was in tension, so it is here. FHB also was in tension, so it is here. We know it. And now, why I am using FBJ to be downward? Because this 32 is upward and FBJ, if it is upward, then it will add to 32, which will not be balanced by 8. So this has got to be downward. Do you agree with me?
Yes, sir.
Other cadets do not speak. Either they are understanding or they are shy. Do not be shy, my dear friend.
Yes, sir.
Yes, sir.
Yeah. Asking a question is a very innocent thing. We have all the time to go slow. So this 32 minus 8 is a upward 24. To balance it, we need something. So FBJ sin theta is a 32 minus 8. So FBJ is a 24 minus sin theta. Okay?
Yes, sir.
Now FBC should be equal to FAB plus FBJ cos theta. FAB plus FBJ cos theta. FAB is a 40 by 10 theta. FBJ cos theta is a
24 by 10.
24 by 10 theta. So total is a 64 by 10 theta.
So why FBG is not along FBC?
Pardon?
FBJ is not along FBC.
Along with y cos theta में भी
उसका FBJ का हमने दो कंपोनेंट है, एक x और दूसरा y. जो y है, ये y कंपोनेंट जो है वो y कंपोनेंट और ये 8 डाउनवर्ड दोनों मिलके ये 32 को खत्म करते हैं और वर्टिकल फोर्स 0 हो जाता है. और ये जो x है, x जो है FBJ और FBJ का x कंपोनेंट FBC को मिटाता है. तो FBC should be in a tension only. Is this clear now?
Yes.
हाँ, ओके. तो आप एक बात समझ सकते हैं कि ये टेंशन में है ना, तो उसके साथ में ये एलिमेंट टेंशन में है, तो उसके साथ में ये एलिमेंट भी टेंशन में आया. और यहां पर टेंशन था 40 by 10 थीटा, यहां पर हो गया साहब 64 by 10 थीटा. टेंशन बढ़ गया. उसी तरह से ये कंप्रेशन में है और ये भी कंप्रेशन में है. यहां से आए यहां पर कंप्रेशन था 40 by sin थीटा. यहां पर कितना हुआ, बढ़ा के कम हुआ? बढ़ गया. देखते हैं, चलो, मुझे भी याद नहीं है. मुझे भी याद नहीं है. वो 40 by sin थीटा था. FBJ जो है वो 24 by sin थीटा कम हुआ. राइट? करेक्ट?
Yes.
अच्छा. अब इतनी एक्सरसाइज करने के बाद एक मजे की बात हम सोचते हैं. वो जाके होगा, अब यहां से हो गया, यहां पर भी हो चुका, यहां पर भी हो चुका. नाउ वी कैन गो टू द पॉइंट J. Suppose we come to the point D. What will be the force in a KD?
0.
दोस्त 0 तो नहीं होगा,
सर बहुत कम नहीं हो जाएगा?
नहीं बहुत कम भी नहीं होगा, वो 0 भी नहीं होगा। यहाँ पर ये 8 है ना, 8 is a only force downward, so this also must be 8 upward over here. There is no other way, because these forces are horizontal, they cannot have a vertical component. Am I right?
Yes, sir.
Right? So
Yes, sir.
if you look at the truss, you can always find out some components without doing any calculation. So here also, if this is upward 8, then here also there is a downward 8 at this point, and a KD is in tension. This was also in a tension, and here tension is a 8. Here tension was 32. Here it will become 24. And here it will become even less than that. Then again, here it will be the same as this one. This will have a same as this one. But now let us work ahead and find a further some forces. हम जॉइंट J पर आए हैं अभी. Joint J, again have a look where it is. It is over here. Correct? On the joint J, this is a upward force acting downward. Why we know it? Because we are given. We are knowing FHJ and FBJ. Direction and magnitude also is known. We do not know FJK and FJC. Now, one thing is sure, FHJ is like this, FBJ is like this, FBJ has an X component like this. So, FJK should be like this and this only. No other way. Am I right, my dear friends?
Yes, sir.
हाँ?
Yes, sir.
FHJ ऐसे लगना है, FBJ ये डायरेक्शन में है, उसका X कंपोनेंट यहाँ पर आ जाएगा, तो ये दोनों को अपोज करने के लिए ये JK ऐसे ही जाना चाहिए. करेक्ट?
Right, sir.
So FJK is equal to FHJ plus FBJ cos theta. So it is 40 by tan theta plus 24 by tan theta. Right? So that is
Right.
equal to again 64 by tan theta. FJK. And FJK is in compression. Right? Because it is pushing the node. So node is pushing it. Right? So here one thing is sure, that again now FBJ is upward like this. That much minus 8 should be equal to, FBJ is upward and this is over here. So this is an upward component. So this FJC is acting upward and 8 downward. FJC is a FBJ sin theta. FBJ sin theta is a 24. Minus 8 is a 16. So net force is a 16 upward. So this has to be a 16 downward only. Do you agree with me? बच्चों बताओ.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Anybody else has a curiosity? Then we can still discuss. As I told you, this is 32. हमने कैलकुलेट किया. This is 32. ये हो गया 16 और ये है 8. समझे? आधा होते जा रहा है. आधा क्यों होता है? कोई बताएगा? हमेशा आधा नहीं होगा, लेकिन ऐसी ट्रस में अगर लोडिंग ऐसा है तो ये होता है. वो क्यों होता है?
Symmetry की वजह से.
बहुत रीजन है, वो हम बाद में सोचेंगे. राइट नाउ आई वांट ऑल ऑफ यू टू डेवलप योर मसल्स, योर थिंकिंग मसल्स बाय फर्दर वर्किंग ऑन ए. वी हैव फिनिश्ड दिस जॉइंट, दिस जॉइंट, दिस जॉइंट एंड दिस जॉइंट. 4 जॉइंट मैंने खत्म किए हैं. अभी मैं चाहता हूं कि बच्चों ये क्लास खत्म होने के बाद ही मैं आपको ये भेज देता हूं गूगल ग्रुप पे. तो आप ये जॉइंट, ये जॉइंट और ये जॉइंट मैंने तो सॉल्व किए हैं, लेकिन आप इंडिपेंडेंटली करें. आंसर गलत आए तो या तो मुझे चैलेंज करेंगे आप कि सर आपकी गलती है, ये सही नहीं है, या तो फिर गलत आए तो आप सुधारोगे तो ये बात तुम्हारी होश में आ जाएगी. एंड वन थिंग, right now, if you do it today, these 3 joints, then I swear you have mastered the art of solving a truss. हाँ, तुम्हें ये रिएक्शन निकालना आता है. थोड़ी चीजें ऐसी है कि कोई जगह पर ऑब्जर्वेशन से ही थोड़े फोर्सेस मालूम पड़ जाते हैं. वो प्रैक्टिस हम करेंगे, काफी प्रैक्टिस करेंगे, जमकर करेंगे. ये सब्जेक्ट में तो मैं आई अश्योर ऑल ऑफ यू that you will surprise even your own self. You will be securing a great marks. Okay? But today you have to work this much, and I have shown to you that one joint does not take more than 5 to 7 minutes. तो अपने क्यूबिकल में कोरोना डेकोरम को रखते हुए मास्क लगाओ, 3-3, 4-4 फीट दूर खड़े रहो, 4-5 कैडेट, और सोच लो आप कर सकते हो या नहीं. पूरे चांसेस है कि आप में से कोई कहेगा मुझे कि सर आप अननेसेसरीली ये प्रॉब्लम को लंबा कर रहे हैं. अगर ऐसा सोचेंगे ना तो ये जल्दी हो जाएगा. और ऐसी मेथड भी है. दैट मेथड आई वांट ऑल ऑफ यू टू फाइंड आउट एंड इंक्रीज योर सेल्फ कॉन्फिडेंस. वी विल बी सॉल्विंग स्टिल 4 more trusses, but each truss, now I think we will be solving 3 more trusses now, because each truss will take a 1 complete hour, and we have to go ahead also. I don't want any of your to be completed. Any of your thing to be confusion to remain. Okay, we will solve this was a bridge truss. We will solve some other truss also. Correct? And you need to practice, because what happens if we don't solve the problem? Now offline exam will come, detailed questions will be there, and if we don't practice, then we will end up in a problem. Even though we know the how to proceed, our method will take a lot of time. Either we'll lose in the time or in some other angle. Okay, friends, it is 4 o'clock. A time for all of you to join in your next class. There are 32 cadets present overall. I am sure some of them are maybe with somebody else. But do come to the class in time. We will make it interesting and I will be finishing it at the earliest. CR, send me the numbers of those who have some issue and could not be present in the class.
Dhruv is with me. Excuse me, sir.
Yes.
Sir, Dhruv is with me. Dhruv Tyagi.
Pardon?
Sir, Dhruv Tyagi is with me.
Okay, fine, no problem. Let CR send me a message. Somebody may not be able to attend it for some reason. Somebody may be in a sick bay. So I know that this cadet has not attended this class, so he will certainly not know as much as a Daksh or a Prathamesh or a Chaitanya or a Bhuvan, etc. Right? It is my job to catch him and make sure that he has studied on his own, or I have to teach him again. Because we are expecting a excellent result. I want IMU to say that in engineering mechanics, TMI cadets are topping. Okay? Have a nice time and a Jai Hind to all of you. I am leaving the meeting. When the next sir comes, you make him a
Sir, I'm here now. Okay, just make me host and